Okay, we are on the second video for day 2. This is Unit 1, Activity 4, Forces and Free Body Diagrams. What we're going to learn today is the difference between kinematics, which is the study of movement, and dynamics is why things move. Things move because of unbalanced forces. So if we have something on a desk and one person is pushing this way and one person is pushing this way with equal force, nothing's going to move. So objects move because of unbalanced forces. So a force, this is important, a force is a push or a pull. A force is measured in something called newtons. So we are going to use, big N as newtons. So that's mass times acceleration to get a force. We will look at this more in the next unit, but force is equal to mass times acceleration. You can forget that for now, but we will get there. Now, there are different types of forces. There is the force of gravity. So every object that has a mass has a gravitational pull, and it will pull things towards it. On the Earth, we have a gravitational pull. It's 9.8 meters per second squared is that force of gravity pulling down. Another force is an applied force. So if a person was pushing on a box, that's an applied force. So it's pushing in that direction. Now, if that box was on the ground, we would have the force of friction. So the force of friction would be acting opposite to the applied force. So if you tried to push that box, then the friction between the ground and the box would be fighting this. Now, another force is a force of tension. Sorry for the messy writing. I'll write that out again. T-E-N-S-I-O-N, tension. So if a box was hanging on a string, there's a force of tension on that string. Now, we could parse this and get finer and finer and finer with these forces. So for example, air resistance is a form of friction. But we're going to try and keep this simple and straightforward if we can. But the one that people have the hardest time understanding is what's called a normal force. So for every action, there's an opposite and equal reaction. So I think everybody can understand gravitational force pulling us towards Earth, or an applied force when we push on a box, or a force of friction or tension. But a normal force acts opposite to a surface. This one takes a while to get it through your head, but if we have a table and we have a box and the box is being pulled down by the force of gravity, there's an equal and opposite force given by that surface called a normal force. Try something. Put your hand on a tabletop and imagine what that feels like. Now push down harder. It feels like the tabletop is pushing back on you. Whenever something is up against a surface and you push, that normal force will push back. Hint for a test or quiz, if you've got a book up against a wall and you push towards the wall will push back. So there's your force applied, there's your normal force. So the normal force isn't always going opposite to gravity. Sometimes if you push against a wall, the wall is acting to push back on you. So you have a normal force. If you don't understand that normal force, I hope you'll take the time to look it up. Once again, I think people get the force of gravity. I think they get applied force. I think they get friction. I think they get tension. The tough one is whenever something is acting on a surface, the surface is acting on that object. So opposite and equal. So this normal force is equal to the force of gravity. Now, for something to move, there has to be a net force. So a net force will cause motion. So if somebody's pushing this way with an applied force of 30 newtons, and there's a force of friction coming backwards at 20 newtons, there is a net force of 10 newtons to the right. Sorry folks, I'll show you that diagram. I'll say that one more time. If there's a force of 30 newtons going to the right and a force of friction of 20 newtons going to the left, the only way we get motion is if we have a net force. And a net force is when one force is bigger than another. And that will cause motion. So things can be additive too. So say one person was pushing this block, and then a second buddy jumped in, excuse my drawing, and they were giving a force of 20 newtons. We'd have 50 newtons now altogether going in the right direction. Hey, I think that's it for this. As long as you understand that whenever we have objects, we can have forces on them, and we can draw diagrams to try and explain them. So for example, we have a block on a table. There's a force of gravity of 20 newtons. That means the normal force will be 20 newtons. Let's say that somebody is pushing that to the east, and that force applied is equal to 50 newtons. And the force of friction always acts in an opposite direction to the applied force. Think about that. If you push a block across a table to the right, the friction is slowing it down, so the friction is going back to the left. The only other thing I can think of that's important is an applied force is only there when the force is being applied. So in other words, as long as a person keeps pushing this box, he will have an applied, or that person will have an applied force of 50 newtons. If you hit a ball with a baseball bat, I want you to try and think about this one. This one's sort of important in physics. If you hit a ball with the baseball bat and the ball's flying through the air, there is no longer a force being applied by that baseball bat. It was only applied at the point where they make contact. The reason this ball is moving through the air is because there's no force left to stop it from moving through the air. So what force is on this ball right now? There's no longer an applied force because the ball is no longer touching the baseball bat, but there's a force of gravity pulling that ball down. There is probably forces of friction from air resistance too. In this unit, you probably won't use air resistance as a force though. But if you wanted to show the forces on that baseball, that's how you would do it. Remember, a force can only occur when something is touching something else. So this force got the ball moving in the first place, but it's no longer on the ball. There's only a force of gravity pulling this ball down and the force of friction from air resistance.